Good afternoon, everyone. I would like to tell you a story of Jason. He was slightly older than me, let's say he's mid-50, got some savings and decided to invest in real estate. And this is not a joke, unfortunately. The story was happening in a country far away from here. We don't need to name the country, but it was a well-developed country with many high-rise buildings. So he decided to invest in an apartment in a really premium location, modern building, fully, let's say, up-to-date fire detection system, sprinklers in every apartment. So he thought, okay, it's a good investment. Happened to be that he was also having stack of cash in his apartment because he was preparing for the wedding of his daughter. The fire started in that building, not in his apartment, many floors above him. Unfortunately, the sprinkler system didn't work. And the fire spread to the outside of the building envelope and damaged many apartments. All his cash was gone. All his life savings was gone. Of course, he had insurance. Over the time, he'll get it back. But the question is, why the sprinklers didn't work? It was new building. So there is always a conflict between the, let's say, building no owner or, let's say, investor, the authority having jurisdiction for any modern country, and then the people who wants to move in and, let's say, owners of the apartments who wants to start getting money from the tenants, and, let's say, either authority having jurisdiction or whoever is responsible third party for final commissioning of the building. Because if you're getting a system worth, let's say, $100,000, which is not only the fire pump, not the controllers, but the whole, let's say, active system related to the suppression, or at least the controlling of the fire in a given tower. Now the question is how to balance the needs of the owner who wants the building operated as soon as possible, and then third party who wants to check that everything is okay. Because if you're buying a new fire pump system, which is UL listed or FM approved or both, then you should be highly confident that there is no need for any long and proper commissioning of that system. And my aim of this presentation today is to show that this is far from true. NFPA is today quite often on the agenda or on the screen. So my whole presentation is about the document or a standard developed by NFPA, which is a standard for the installation of stationary pumps for fire protection. What I'm going to focus today is only on one aspect. So no design, no selection. It's just the final acceptance testing, let's say initial testing of the system, not only the fire pump. We as ESL, I will come back to the checklist in a second. We as ESL, we are located in Dubai, and since January 2024, so almost for last 2 years, we tested more than 700 installations. Some towers were, let's say, having few sets of pumps depending on the height. So it was like 700 plus projects. And based on that, let's say 2 years experience, almost 2 years experience, I wanted to show you why the initial testing of systems is crucial, and what can go wrong, which can lead to the situation that in the event of a fire, a new fire pump will not work. I'm not even touching now annual maintenance or annual testing. I'm talking today only of initial testing. Let's call it acceptance testing. We have prepared a check. I mean, we discovered that some of the contractors, they don't know NFPA 20, which they should. It's a requirement of the UAE code, but they don't know it. So even we prepared a checklist showing step-by-step guide what will be checked by us as an initial testing. So the most common failure we observed is that the pump is not getting enough water. So if the pump is not getting enough water, it cannot deliver the fire demand or let's put it a different way, the required amount of water for a given building, for a given site. So the problem is what are the most common reasons why the pump is not getting enough water? There is nothing wrong with the pump. Out of those 700 plus projects, I don't remember any pump not working, in that sense that there was a fault at the pump. FM, UL pumps listed or approved, no problem with the pump. The problem is always the installation. Based on our 700 plus site experience, I'm not talking Abu Dhabi, I'm talking now only the sites we visited ourselves. I'm not saying also there's a common problem. I just want to show you why testing is important to elevate the quality of the systems as a system. So first example, some of these examples are obvious, some of these examples are more sophisticated. The graph I'm showing, basically, whatever is on the site, which is blue, should match whatever is in orange, which was in the factory. And now the reason is why it's not delivering as it should be. Because there is obstruction, there may be obstruction, and it's more often than we thought. So pump cannot deliver if it is not getting enough water. So if it's obstruction on the way, and I'm not talking about any, let's say, unwanted obstruction, something which is there. So in the tank, there is anti-vortex plate, and it's artificially reinforced. There is not enough water getting. Because the pumps are very often specified to a given site, that really affects how much water is getting there. Another interesting example from this country is that Dubai and UAE as a country, like most of the countries in the world, operate on 400 volts. We're talking three-phase. However, there are a few countries in the world. In this vicinity will be Qatar and Oman, which operate 415. You may think that this 15 volts is not making big difference, but this is like 3.7% voltage drop. However, if the pump is set for a given requirements and whoever is buying the pump doesn't want to pay more, this is at least 5% loss on torque. And the pump, by this 15 volts drop, may not work properly. So if whoever specified the pump wanted to save few dirham and buy the pump, which is really for another country, it is not multi-voltage, which should dual voltage, it will not perform the way it should perform. Another example, as I said, pump is not getting enough water because this is example of vertical turbine, and really we saw it happening. The pump needs clearance below. And if it's improperly installed, it's nothing wrong with the pump. It's just how it's installed in the water tank. If there is not enough clearance, the pump will not deliver the amount of water required. And then it gives the situation that the delivery water is below the requirements for a given pump. Less sophisticated examples, the UAE code, and I guess not only here, requires that there should be two water pipes coming from the tank from the water tank to the common heater and then the pumps. Sometimes, especially with a warehouse, we see only one pipe. Sorry, that's the laser. So it's only one pipe, which means pressure losses, friction, and that's give to the situation that the pump is not getting enough water. The code is talking about two pumps. Maybe it's not that obvious on this drawing, but at least there are two return pipes here, so you can see two red ones. And this is my best example for this presentation. What you see is outside is not a big problem because the water is flooding outside. So I wouldn't say this is the issue. The issue is on the left-hand side, but now the photo is without the water. Please imagine that we found a pump room with no drainage at all. And for your information, the electric pump, it's electric motor, just current, and it works. However, the diesel pump, it's cooled by water. So operation of the diesel pump lead to the situation that is always water being discharged. I don't know if you use a motorboat or you travel by motorboat somewhere, always the engine at the back discharge the water, which is the cooling water. So imagine how long this pump room can operate on the diesel pump if the water is collecting inside. And again, this is not the problem of the pump. The problem is of the installation. Another problem which can happen, and it will kill the pump over the years, it's too short suction, which is not according to NFPA 20. In a nutshell, sorry, I'm just mixing next slide with the laser. This should be 10 diameter of the pipe, which we're talking about 1.5 to 2 meters length. What is happening? the imbalance of the pressure, it's killing the bearings of the pump. So the pump will perform initially very good, but over the time, the bearings will be gone. And we yield the situation that the pump will be not operational at all. And situation, unfortunately, quite common. Concentric installation instead of eccentric, just to explain it. This is how it should be done. This is how it's done on this photo. I saw a pump where the reduction from 8 diameter to 4 diameter, sorry, 8 inches to 4 inches was with this arrangement. It gives extra air bubbles or air pockets to the pump, which really affects the performance very badly, especially if there's a big reduction. So those type of failures can be really spotted not only when somebody comes and starts the pump for half an hour or 10 minutes. It's really comprehensive procedure described in NFPA 20 in chapter 14, which clearly mention what should be tested, how should be tested, and why should be tested. And only then we can ensure that a given system should be operational during the fire, or we have a high confidence that this will be operational during the fires. As I said, I'm not touching any maintenance. I'm not checking any regular annual or three-year testing. We're talking only initial commissioning. So my message is the pumps are very good, but we have to improve the way they are installed here or in any other country where the fire pumps are being used. Few more, just to add with that, issue of the ventilation. As you know, diesel engine requires air to operate, like your car requires air to breathe, unless you have electric car. If there is not enough air provided to the pump room, the diesel pump would just basically choke and stop operations. And from the diesel pump, what we have observed also, there is a whole bunch of problems with the diesel tanks. They either too small, or they don't have a ventilation, or they not filled properly in terms of the amount. And I'm talking only new projects. So those are, let's say, auxiliary situation, but that's something also affecting the pump performance. And then negligence of the installation team, which forget to understand that the water and electricity doesn't like each other, and all electrical installation which are inside the water tank when there is a discharge of the cooling water should be really waterproofed. And the final slide of my presentation, what you see is just explanation for those who are not very familiar with the, let's say, the valve on how the valve looks like. What you see in the green rectangular shows the closed valve, and believe me, it shouldn't be closed on the active system, because then the system doesn't work, and it happened unfortunately as well. Which may yield to another topic of annual inspections. But as I said, today I'm just highlighting the issue of the initial inspections. So thank you very much for your time. Thank you for joining me after the lovely lunch break and the networking event. And should you have any questions, I'm sitting here in the second table, and of course I will be available later during the final break. Thank you very much.